Stay up late though it rains. It's good, but it is never the same. Never really the same.
Hi, I'm Juha and I'm a hockey player here at USC. I will be going through some physics concepts and examples with you this semester. And remember, just like on the ice, there's no such thing as luck in physics. Just keep your head up and work hard. In this problem we have accelerating bodies, so we have to resort to Newton's second law. So two boxes have been connected via a pulley and a rope, and as the figure shows, the mass 2 is accelerating down, which means that the mass 1 is also accelerating. And we would like to solve the magnitude of this acceleration. So we have two bodies, massless rope, so two figures of, or two free body diagrams. So let's draw the first one for M1. So there's the tension force from the rope, of course, like this. What else? We assume there is no friction, so then the only other force acting on M1 is gravity. So it has weight M1g, and this is of course tension in the rope, T. And again, we have forces that are not perpendicular, so we have to divide one of them in its components. And we can be smart about how do we define our coordinate axes. So in this case, when we have an incline, the most useful way usually is to define using that as a reference. So let's say our x goes this way, and in fact, yeah, it doesn't matter. Let's have y like this. So when we are talking about forces in x direction, in this case, we mean along the incline. So the t, well, first of all, there's an incline that has angle alpha, like that. So we can divide the gravity in two components. One along the incline, like this, and then another one perpendicular to the incline. And the angle alpha, in this case, is found here. So what does this tell about now the forces? So if this is m1g, so this must be then sine alpha times m1g. And also this would be then cosine alpha m1g. In fact, we don't need this one because we are not dealing with the friction, so, but we can just have it there for reference. So what is the sum of all forces in x direction, in this case along the incline? According to Newton's second law, mass of the object times acceleration, whatever it is, acceleration 1. So let's sum these forces. We have positive direction is to the right along the incline, so t is positive, and minus m1g sine alpha equals m1 acceleration 1, like this. And we can arrange by bringing t to the other side, so m1 is on the both sides, so that's a common, so we have acceleration 1 plus g times sine alpha. In the same fashion, the free body diagram for mass 2 is as follows. So gravity acting down, m2g, and the tension in the rope, which is uniform throughout the rope, is pulling it up like this. And how do we choose our coordinate axis in this case? Well, we don't need this x direction because the movement is up and down, so we just decide which way is positive. So let's say it's going to be down because we have the impression that the acceleration is going down as indicated by this. So in that case, the sum of forces in the y direction is the positive one, so m2g minus t equals m2 times the acceleration of object 2, like this. And here we can plug in what is t. We just evaluated it with the mass 1, so combining these two, m2g, and then t from here. Let's open this up. m1 a1 minus m1 g sine alpha equals m2 a2. Now, what about these sub-indices a1 and a2? Well, a is just the, or a1 is the acceleration of mass 1 and m2 is the acceleration of mass 2. But because they are tied by this tight rope and they will be moving in unison, so this acceleration must be the same in magnitude, although they are different in direction. But that doesn't matter because we are just playing with the magnitudes in this expression. So now we can combine some terms here. So g times m2 minus m1 sine alpha, and then we take this one to the other side. We have a times m1 plus m2. From here we can solve for the acceleration to be g times m2 minus m1 sine alpha divided by m1 plus m2. So let's think about for a while, does this result make any sense? So let's imagine there was no m1. So this one and that one would disappear, and the acceleration would be just g, because it would be m1 or m2 over m2, which means that the object would be in free fall. And that makes sense because there's no mass in the rope itself. And what about this term? So sine alpha. This means that if we have a steeper angle, this term will be less. So acceleration would be less. And that makes sense because in that case the m1 offers a larger resistance to the movement. So these kind of sanity checks are always useful if you can make them after you obtain the actual result. And in this case they check out, so we are happy with our answer.